Hi, my name is Mariana Ruelas, and I'm going to be doing a question from section 11.1, number 7 from the online home math lab, and which is section 11.1, number 25 from the textbook. So the question says, in a clinical trial of a vaccine, 12,000 children were randomly divided into two groups. The subjects in Group 1, the experimental group, were given the vaccine, while the subjects in Group 2, the control group, were given a placebo. Of the 6,000 children in the experimental group, 73 developed the disease. Of the 6,000 children in the control group, 101 developed the disease. Determine whether the proportion of subjects in the experimental group who contracted the disease is less than the proportion of subjects in the control group who contracted the disease at alpha equals 0.10 level of significance. So first we're going to go ahead and we need to differentiate which one it is. We need to state what's our null hypothesis and our alternative hypothesis. Alright, so I went ahead and labeled which is p hat 1 and which one is p hat 2. So the first proportion is the experimental group, which is group 1, which is stated right there. Subjects and group 1. The experimental group, so that's this one. And then the experimental group, the control group is the second group, which is this one. So it is asking that it wants. So initially, the null hypothesis is going to be P1 equals to to P2, which is going to be, you're going to automatically just cross that one out. So now we're left with those three. Alright, so it's saying P hat 1 is contracted the disease less than, determine whether the proportion of the subjects in the experimental group who contracted the disease is less than the proportion of subjects in the control group, which is this one. So it's going to go ahead and be this one. So now that we went ahead and got our null hypothesis and alternative hypothesis set up, we need to determine the test statistic. Since we're trying to get the test statistics of two proportions, we're going to go ahead, since the two values that are being placed are not, they're both independent, we're going to go ahead and use this formula. So we need to be able to get a p hat of 1, and then the p hat of 2, n1, and then n2 and p hat. So right here, this is how we get our p hat. So we're going to go ahead and do that. Well, first we're going to go ahead and identify x1, x2, n1, and n2. So our n1 for group 1 is going to be the subjects in group 1 right there. So 6 is going to be 6,000. So we're going to go ahead and write that down. N1 equals 6,000. And N2 is also 6,000. Just right here. So now let's go ahead and get our x1 and x2. So for our x for the group 1 is going to be 73. Since of the 6,000 in the experimental group, which is group 1, 73 developed the disease. So that's our x1. So now for x2, we go ahead and look at group 2. So of the 6,000 children in the control group, 101 developed the disease. So that's our x2. So now for our p hat 1 and p hat 2, we know that p hat equals x over n. So since we're trying to do p hat 1 and p hat 2, so let's go ahead. X over n. So this is x1, x1, x2, x2. So our x1 is 73, and then our n1 is 6,000. and our x2 is 101. So now we go ahead and divide that. So I went ahead and divided each one, and I got that. So now we're going to go ahead and plug all this information in. Oh wait, we need to do the p hat, which is part of the equation, which is x1 plus x2 over n1 plus n2. Now I'm going to go ahead and divide that, which gives me 0.0145. So now that we have all our information ready, we're ready to go and plug it into the formula. Alright, so this is our formula, so now I'm just going to go ahead and plug in everything, all the little sections that I found for already, which is p hat 1 is this right here. So I'm just going to go ahead and put 1038 minus p hat 2, which is 0.0168 over, so p hat is 0.0145, and it's going to be 1 minus 0.0145, and so this is going to be 6,000 plus. Alright. So what I'm going to do is just do these, multiply these two, and then go ahead and divide. Well, we'll do this portion right here first. So, well, hold on. I'm going to go ahead and do this first, the top portion, and I'm going to go ahead and do this portion right here. Alright, so I just went ahead and subtracted these two, which got me this, and I multiplied this times this, which got me this number, and I just squared it because I just multiplied the inside first. And then for this right here, I divided 1 by 6,000, and then since they're both the same, I multiplied that value times 2, which got me 0.003. So now what I'm going to go ahead and do is plug these two into the calculator, and then, well, I'm going to initially plug this one into the calculator, and then multiply it times this value, whatever the square root of 0.0003 is. So I went ahead and multiplied these two, which got me 0.002. So I went ahead and divided this, and it gave me negative 1.5. So now what we're going to have to do is get the p-value for that, which is asked for right here. So now we go back to our non-alternative hypothesis. So we need to, since we already have we have the alternative hypothesis, from there we're going to determine what side it is going to go, either from the right side of the test statistic or the left side. So since P1, so pretty much P2 is greater than P1. So from there we're going to know that it's going to go to the left. Now we go back to our non-alternative hypothesis. So for the alternative hypothesis, we're going to be able to identify what side the test statistic is going to go to, either right or left. So based on here, alternative hypothesis P1 is less than P2, so it's going to go to the left. And for when we're dealing with proportions, we're going to use normal CDF. So we're going to go ahead and plug in the test statistic into the calculator, and going to the left side with a 0 mean and 1 standard deviation, which will get us our p-value. Alright, so here we are in the calculator. So now, since it wants the left side, we're going to go ahead and plug in to the negative 9999, and we're gonna go ahead and plug in the test statistic, which is negative 1.5. And it's from mean of 1 and standard deviation. Mean of 0 and standard deviation. So this is gonna be our p-value. 0.06. Since it's asking here, round to 3 decimal places as needed. So we're gonna use the first 3, but we're gonna round off this 6 to a 7 since the 8 rounds this one off to the 7. So it's gonna be 0.067. So now that we know what our p-value is, let me go ahead and put it into the little box right here. So it's 0.067. And this was negative 1.5. Alright. So now that the other portion of the question is asking, what is the result of this hypothesis test? So since the p-value is less than the level of significance, which is 0.10, whenever the p-value is less than its level of significance, we're going to go ahead and not reject the null hypothesis because there is not enough evidence. So it would be this one. Do not reject the null hypothesis because there is not sufficient evidence to conclude that the proportion of subjects in the experimental group who contracted the disease is less than the proportion of the subjects in the control group at the alpha equals 0.10. So it's this one.